All right, so use the following statements to answer the questions below. Two angles form a linear pair because they are supplementary. Two angles form a linear pair because they are supplementary. We're going to first write this statement in if-then form and then determine if it's true or false. So if two angles form a linear pair, then they, let me make that a little bit smaller so it's nice and slick and not all one line. Then they are supplementary. So we put it in if-then form, so we kept the order the same, we made it sound grammatically the best we could, and determine if it's true or false. Well, linear pairs are supplementary, so that's true. Identify the hypothesis of this conditional statement. So it's just going to be two angles form a linear pair. Remember, don't include if. It's everything after the if. And then similarly, identifying the conclusion of the conditional statement, it'd be they are supplementary. And again, don't include then. Why? I guess the best way to explain it is you just want the closed statement. You just want the statement part, not the if, the then. We only want the parts that matter the most. All right. Now we're going to rewrite the conditional statement as a contrapositive. All right. So again, individually it's easy to remember each statement, but there's so many of them you might get confused a little bit. Contrapositive is converse, then inverse, or you could do it in either way. Most letters, contrapositive has the most letters. It's the most work. So I got to take this statement, I got to take the conclusion, they are supplementary, and negate it. So actually let me do this. If two angles, again, we try to make it sound grammatically as best as possible. So I'm going to keep two angles up front, but then say if two angles are not supplementary, then they don't. Again, let me make this a little smaller, that way it's all on the same thing. Then they don't form a linear pair. All right, and again, supplementary was the conclusion, linear pair was the hypothesis, so I swapped the order and I negated it. Okay, so that's the contrapositive. And determine if it's true or false. Well, remember, to really limit the amount of thinking I'm doing, I can say the conditional is true. And remember, contrapositive, same truth value as conditional statement. So the original statement. All right? It's the same truth value. So this statement is also true. If they're not supplementary, so that means that we have two angles that don't add up to 180 degrees, then they don't form a linear pair. Well, that's true. They can't form a linear pair if they don't add up to 180. All right? Next, we got the good old inverse. All right? So I like to say inverse not. Inverse not. So same order. So as my conditional statement, so I'm going to say if two angles don't form a linear pair, then they are not supplementary. So remember, inverse not, I just negated both hypothesis and conclusion. All right, now, is this a true or false statement? This statement is false. So it's saying if they don't form a linear pair, then they can't be supplementary. What if I have a 90-degree angle chilling here, and then a 90-degree angle chilling here? These two angles are supplementary. They both add up to 180 degrees, but they're not adjacent. They don't form a linear pair. So they can still be supplementary without forming a linear pair. That's why it's false. All right, and then we're going to rewrite the conditional statement as a converse. So this one, I like to say swap order. You're putting your Converse shoes on the wrong feet. You're swapping the order of your shoes, swapping the order of the hypothesis and conclusion. So as the original conditional statement, it's going to be if two angles are supplementary. If two angles are supplementary, then they form a linear pair. Okay. Now, something I forgot to do in this last one is how the order was still the same. So, really fast with inverse, linear pair was in the same order, and supplementary was still in the conclusion. Now, supplementary got swapped to the front, linear pair got swapped to the back. Now, and again, I don't even really have to do much thinking to know if it's true or false. I know that converse is the same truth value as inverse. So I'm kind of cramming. I got a lot going on right now. Remember, you guys can always pause and rewind. So converse and inverse are always the same truth value. So since the inverse is true, or excuse me, it's the inverse is false, I know the converse is false. All right, they have to be the same. All right, and above we could use the same thing. We have two right angles chilling in space, or we could say, well, I have 70-degree angle here, and then I'm not doing a very good job drawing. 110-degree angle right here. These two angles are supplementary. They add up to 180 degrees, but no, they do not form a linear pair. So that's how we got that. All right. And then we're going to rewind a little bit here with number 5. We're going to determine if the closed statement is true, then write the negation and determine if the negation is true. So fall begins in September. That's true. The first day of fall is always like September 21st, 22nd, 23rd. It like seems to switch a day or two every year. So fall does in fact begin in September. I always feel like the first day of real fall, September 1st. But anywho, negating it would be keeping the same statement, fall, but just putting not in it. So let's say, does not begin in September. And since I negate it, it's changing the truth value, and that's false. All right. Vertical angles are not congruent. That's false. Vertical angles are congruent. And then to negate this one, we're not going to say vertical angles are not congruent. We're just going to remove the not. Notice how the not disappeared. Vertical angles are congruent. True. And then last one we have Mr. Oswalt is funny. Obviously true. And then something you'll never hear anyone say, Mr. Oswalt is not funny. And obviously that's false, because I'm hilarious. Alright, biconditional stuff, stay tuned.